So let's look at the rate of change. The rate of change is nothing but our slope. Slope means you have a change in y over a change in x, or a difference in y over a difference in x. Some of you are used to seeing it y2 minus y1 over x2 minus x1. That's how we wrote the slope. That's how we wrote the slope. So now what's different is that we're using the function notation to write slope, and we're calling it rate of change. So instead of y2, we have f of x2. Instead of y1, we have f of x1. And that's our difference between them. So let's go ahead and take care of our example. So when they tell us to find the rate of change, that average rate of change, automatically we know to do the same stuff that we did when we found slope. Again, the difference is the way that we're writing it now. So for number 1, they're already giving me my x1. I just have to plug x1 into that function notation. So instead of it being x1 is negative 1. We're looking for x1 is negative 1. So instead of f of x1, I need f of negative 1. So let's get the f of negative 1. We're going to plug negative 1 into that 6x plus 1. I made a boo-boo. I'm supposed to be plugging in negative 1, so I'm supposed to write my parentheses wherever there was an x and replace it with a negative 1. So 6 times negative 1 is a negative 6. Negative 6 plus 1 is negative 5. Now I need to do the same thing with that second value that they gave us, a 4. x2 is 4. So I go to the function notation. And instead of using x2, I use 4. So I obtain my f of 4. So where there was an x, I replace it with 4. 6 times 4 is 24. 24 plus 1 is 25. Now I'm ready to use that formula, if you want to call it a formula, because we already know our slope, so we don't have to think about it as a new formula. So our f of x2 is our 25. So the f of x2, we use the f of 4, so we got a 25. And the f of x1, that's where we use the negative 1, and we ended up with the negative 5. So when it says f of x2 minus f of x1, I'm doing 25 minus negative 5. f2 minus f1. In my denominator, I'm using the x's, x2 minus x1. Notice 25 is where I started on the y, so the 4 is where I started on the x. You see 25 first in the numerator, you see 4 first in the denominator. So 25 minus a negative 5 is a 30. And 4 minus a negative 4 is a 5. And 30 over 5 we can clean up to a 6. So the average rate of change for that first one is 6. So see, it's just complicated things that they're calling it, but it's really simple if we can remember how to do our slip. That's number 1 done. Now let's do number 2. We're going to follow that same pattern on number 2. They're giving us an x1. They're saying x1 is 0. So when I need to obtain f of x1, solve this right. That means I'm obtaining f of 0. And when I need to obtain, when they tell me x2 is 1, that means f of x2 will be f of 1. So let's go ahead and calculate those two. On number 2, my function did change. I forgot to point that out. On number 2, my function is f of x equals x squared minus 5x plus 8. I forgot to point out that the equation changed for number 2. So on number 2, when I plug 0 in for my x on that f of x function, I have 0 squared minus 5 times 0 plus 8. And that's going to clean up to an 8. So that means f of x1 is equal to 8. For the f of x2, I'm plugging in 1 everywhere there's an x. So I'll have 1 squared minus 5 times 1 plus 8. 1 squared is 1. So 1 minus 5 plus 8. 1 minus 5 is a negative 4. Negative 4 plus 8 is a positive 4. So since f of 1 is 4, that's what we're going to use for that f of x2. Now we're ready to use that so-called formula. I keep saying so-called because I want to stress to you all that you already know this. You have it. So we're not going to think of it as something complicated. Okay? So we need to do that f of x2 minus f of x1 over x2 minus x1. So what went with the x2 was f of 1, and that ended up being 4. So that my f of x2 is 4. Now I need to subtract my f of x1. And up here at the top, we did our f of x1. We went with the 0 for x1. So f of 0 is 8, so our f of x1 is 8. So we end up with 4 minus 8. In the denominator, we subtract the two x's. x2 is 1, x1 is 0, so 1 minus 0. Now I can clean up. 4 minus 8 is negative 4. In that denominator, I have a 1. Negative 4 over 1 cleans up to a negative 4. A lot of times when we're asked to find the average rate of change, when they're giving us the values like that, if we end up getting a fraction that's not where we can reduce it to lowest terms or complete that simplification process, then what we tend to do is leave it as an improper fraction. But if it's a word problem and it makes sense to write the answer as a decimal, we write it as a decimal. If we're reading a problem out of a book or out of an online software, we read the directions to see how they tell us to write the answer. And that's the average rate of change.